Hello and welcome to this video guide as to how to service a Honda ECM 2800 generator set. I purchased this unit second hand only a few weeks ago, and whilst it runs great, it's easy to forget this generator is now 21 years old. There are certain components that ought to be replaced for continued reliable operation. Here we have the maintenance items needed for today. First off, we have carburettor cleaner to give the carburettor a good cleaning. Second, we have the engine oil. The Honda GX series takes a 40 weight oil. This is also fully synthetic for ultimate protection. Fairly standard maintenance item here. We have the spark plug. Remember to check the gap before we fit it. We have the rubber engine mounts. This is what is used to hold the engine and the alternator to the frame. These degrade with time and they have come to the time where they now need replacing. Another fairly standard maintenance item, the wet type air filter. And last but not least, we have the generator output capacitor. This is located in the alternator head. It is a fairly standard 20 microfarad capacitor that is used to regulate the AC output. We're going to change it, even though it is still working, because capacitors degrade over time. I always start by draining the engine oil. This way, we can complete the other maintenance items whilst the oil drains from the sump. A used food container makes a great container to catch the oil in, and it can be slipped easy enough under the engine with the top lip cut away. Once the container is in place, you can remove the sump plug with a 10mm socket or spanner, then release it by hand. It's also advisable to remove the oil filler cap. Doing this will allow the oil to drain faster. It's also recommended to change the engine oil when it's hot, as it will have a better chance of removing any sludge or debris that has built up in the sump. Removing the air filter could not be easier. Simply pop the two clips located on the upper and lower side of the filter housing before removing the front panel to reveal the filter. Once the filter has been taken out, we need to remove the 4 M6 bolts that hold the filter housing together. As you can see, this is easily done with an 8mm long reach socket. It is advisable to wear gloves for this task, as this engine has a wet type filter fitted, meaning the filter housing is extremely dirty with oil, not helped by the crankcase ventilation pipe also depositing oily residues into the intake system. Now that the filter holder has been removed, the two 10mm bolts that hold the carburettor to the engine can be accessed. This is a fairly common arrangement for mounting carburettors in small engines such as this, and makes removal relatively easy, especially on an open frame generator such as this one, where we have plenty of room to work. This is also completed easily with a long reach socket set. There is a third 10mm bolt located on the rear of the filter housing. This is independent of the carburettor and simply secures the lower end of the filter housing to the frame, presumably to reduce vibrations. The fuel pipe is attached to the rear of the filter housing by means of a rubber bushing that can simply be pushed out. Likewise, the crankcase ventilation pipe is an interference fit and easily pulls out. Remove the filter housing carefully, taking care not to damage the gasket on the carburettor should it become stuck to either component. Having checked the fuel supply is shut off, a pair of long nose pliers are needed to remove the hose clamp on the fuel line. Once the clamp has been backed off, gently pull the hose away from the carburettor. If you find the fuel line is stuck to the barb and does not move, you can grip the line close to the carburettor and rotate it back and forth several times, as can be seen here, to break the seal. This will loosen the line, which can then be removed much easier. Inspect the fuel line for damage or perishing and replace if necessary. A spare food container is also useful for placing underneath the carburettor on removal. You may wish to drain the carburettor beforehand, but I personally do not bother, as we will be stripping the carburettor down in a moment anyway. The throttle linkage is the last item to disconnect. A spring is used on the linkage to remove any backlash. Unclipping this spring allows the main throttle actuator lever to be disconnected from the carburettor, which can now be removed from the engine. Most problems with carburettors stem from poor quality or contaminated fuel. Ethanol-based fuel is hygroscopic, absorbing water. The water then causes corrosion and therefore introduces contaminants into the system, clogging the jets. It is vital to clean and check the carburettor on an annual basis. Remove the center bolt from the bottom of the fuel bowl using a 10mm spanner or socket. Fuel will spill out at this point, so make sure there are no sources of ignition nearby. Once off, inspect the bottom part of the fuel bowl for signs of rust or corrosion. If there is severe corrosion, a replacement carburettor is advisable and fairly inexpensive. Inspect the float for signs of damage and check that it moves freely on its locating pin. The pin is only held in place by the sides of the fuel bowl, so be careful not to let it drop out while handling it. Remove the pin and lift off the float to allow access to the float valve. Again, the float valve, the black piece on the left, is purely held in place by the float, so be careful not to lose this on your workbench. Finally, inspect the upper portion of the float chamber for signs of corrosion. Use the carburettor cleaner to spray down the main jet orifice, as seen here. Spray at point-blank range in short bursts for maximum cleaning power. Align the butterfly valves up for the throttle and choke to be open, then continue to spray the cleaner in short bursts throughout the carburettor, especially if there are any visible dirt or sludge, paying particular attention to the borings. Clean the fuel bowl and the fuel float, tipping any excess liquid away into the container. Clean the float, especially around the area of the black fuel valve. Once the cleaning is complete, place the float back into position, inserting the stainless steel pin from either end to hold it in place. Once this is completed, we can refit the fuel bowl. There is a small rubber gasket to seal the fuel bowl to the carburettor. Inspect this gasket and check that it is positioned centrally on the carburettor body before attempting to fit the fuel bowl, as can be seen here. Once the fuel bowl is in position, refit the 10mm bolt, first by hand and then tighten with a spanner or socket. Do not over-tighten this, as you will damage its own red felted gasket. It is also worth noting that carburettor cleaner can be used to clean the external surfaces just as effectively if they have become dirty or covered with oil. Shake off any excess liquid to stop it contaminating the venturi and other orifices which have just been previously cleaned. Although perfectly possible to do this with it in place, on this generator set at least, it is easiest to access the spark plug with the carburettor removed. Start by removing the HT lead as shown here from the spark plug, being careful to pull from the plastic boot and not from the HT lead, which could damage the internal conductors. My generator came supplied with a specifically designed tool for removal of the spark plug, but any spark plug socket that can attach to a 3/8 or 1/2 inch drive socket will work fine. Unfortunately, access is limited on this engine thanks to the poor positioning of the frame, so take your time to align the socket onto the spark plug before attempting to rotate it, as it may cause damage. Once the plug has been loosened, rotate the socket by hand to remove the plug from the engine. Despite this being a brand new spark plug, it is vital to check the gap, as this has a huge impact on how well your engine will run. Use the feeler gauge to check it, which if correct should be somewhere between 0.6 and 0.7mm. As the spark plug is located deep in the engine and access is severely limited, I find it easiest to first insert the spark plug into the spark plug socket and then attempt to thread into the engine, using the socket as an additional grip and leverage to my advantage. Take care not to cross-thread the spark plug, It should easily thread itself into the engine without much resistance, providing it is lined up correctly. Take your time over this step, as the cylinder head can easily be damaged due to it only being made from aluminium. Once the plug is fully seated by hand, you can use the wrench on the end of the socket to tighten the plug down. Again, it is not necessary to over-tighten. You run the risk of damaging the threads in the cylinder head as mentioned before, and are simply making it difficult to remove the next time you have to service the engine. The spark plug has inbuilt seals. Let the seals on the spark plug do their work. Finally, once the plug is tightened into the engine, the HT lead can be reconnected. Place the boot firmly over the spark plug and push it down fairly hard. It will snap into place with an oddly satisfying click. Now we can reattach the carburettor. Slide the carburettor onto its studding, checking both the green gaskets on either side. Begin by reattaching the throttle linkage. This process is fiddly, especially for those of us with big hands. However, the carburettor can be slid up and down on the dowels to get it in the ideal position for alignment. Once the linkage has been attached, the spring can be located. This spring takes up any backlash or lost movement in the throttle linkage between the speed governor and the throttle plate, ensuring the engine runs consistently as the electrical load varies up and down. Take the air filter housing and slide it over the two studs, again checking the condition of the green gasket on the carburettor. Fit and tighten the two nuts to the studs to secure the carburettor and air cleaner to the housing to the engine. It is also worth mentioning at this point, it is advisable to test the throttle linkage by hand. The throttle should be wide open and close off when you pull the linkage back by hand. It is vital to check this now, as if it is not correct, you will have no control over your engine speed when you next start it up. Once the two bolts on the fronts have been fitted, remember to refit the third bolt on the back of the filter housing to the frame. You may have to loosen the carburettor bolts once more if this does not line up. Fortunately for me, it did in my case. Having reinserted the air filter housing into the air filter box, proceed to tighten the 4 bolts in each corner. Once this is completed, you can reinsert the crankcase breather into the air filter box on the top left and reattach the fuel hose rubber bushing on the top right. Simply locate the new air filter medium into the filter housing. It should be a snug, tight fit. Locate the air filter cover over the whole assembly, noting that the air intake cover louvers should be facing downwards. Simply snap the upper and lower clips over the front, locking the whole cover in place. Finally, check the choke lever is free from obstructions, and having turned the fuel supply on, carefully inspect the carburettor for any fuel leaks. A great feature on this generator is the fuel strainer. These are usually only fitted to diesel engines, so full marks for Honda for fitting it here. Having checked the fuel supply is off, the fuel strainer is removed in a similar fashion to the fuel bowl on the carburettor. The strainer screws onto the fuel tap directly and becomes free by use of the socket or spanner. Keep a bowl handy to tip the fuel into, which has a great deal of contaminants, as you might see here. The fuel strainer is designed to separate any water that may be contaminated in the fuel. This is often a problem on generator sets such as these, where they are often left outside in wet conditions when running for extended periods. Filtering out the water before the fuel reaches the carburettor is an excellent idea, as it prevents corrosion, which may cause a whole host of problems, and probably explains why the carburettor on this generator is in flawless condition even after 21 years old. You can use the carburettor cleaner to remove any stubborn debris, then wipe the strainer bowl with a clean rag or cloth. Once the bowl has been cleaned, carefully clean the seal before removing the strainer membrane from the fuel tap. Inspect the strainer for any damage. Then clean with carburettor cleaner. Once it has been cleaned, carefully reinsert the strainer back into the fuel tap housing, taking great care to align the O-ring evenly around the edge. Screw the strainer bowl back into the whole assembly by hand, then remove it once more just to check that the O-ring has been lined up. Once you are happy the O-ring is aligned, it can be screwed back in using the socket or spanner. Again, do not over-tighten, you risk damaging the O-ring. Once completed, turn on the fuel supply and inspect the whole assembly for fuel or fuel leaks. Since starting the maintenance, the last of the oil has had a chance to drain from the sump. Clean the sump plug bolt using a cloth and reinsert it before tightening down. Whilst I'd like to cover the fitting of the replacement engine rubber mounts, I feel this is an easy enough task to complete if you've made it this far in the video. It is a tight squeeze to lift the engine up high enough, so removal of the fuel tank may make it easier on certain generator sets. The used oil container can now be removed and disposed of safely. Do not pour this down a drain. If you're impoverished like me and do not have a funnel to hand, you can tilt the frame backwards to give easier access to the oil filler neck and carefully pour in from a bottle. The Honda GX200 takes 600 ml of oil. I find it easiest to pre-measure this quantity of oil out and tip it all in one go. This is easier than tipping it in bit by bit and constantly having to check the oil level. Use a good quality oil, preferably fully synthetic, and either 5W40 or 0W40 for ultimate protection when cold starting. The additional cost of good quality oil is insignificant when you are only using 600 ml at a time for an oil change. A bottle of oil is always cheaper than a new engine. Finally, the oil level is correct when the engine is flat on the ground and the oil level reaches the lower level of the filler neck tube. The last item to be replaced is the output regulator capacitor. Loosen the two screws on either side of the generator head, as shown here, then rotate to remove the plate. Even though this capacitor is still functioning, capacitors larger than 1 inch in diameter can be prone to failing after 10 to 15 years, especially in this environment, as this capacitor is exposed to extremes of temperature as the generator is stored and used. Replacing this capacitor before it fails is essential. If this capacitor should fail, the generator will not produce any AC output. More modern generators use an AVR or automatic voltage regulator. Whilst these give a smoother output, they are not without their drawbacks, and I find that a simple capacitor regulated set like this will often outlive its AVR equivalent and is both cheaper and easier to repair should it go wrong. The capacitor is held in place with cable ties. Cut these cable ties before removing the spade terminals which make up the electrical connections. Be careful not to damage any of the windings as you do this. The capacitor can now be removed. It is unlikely you will find an identical capacitor to the original one. However, this does not matter. Providing the capacitance value is identical, 20 microfarads, and the rated voltage is either equal to or higher than the capacitor being removed, it will work just fine. The new capacitor is equipped with a mounting stud. Remove the bolt from this stud, as we will not be mounting it in this way. and if the bolt should vibrate free, it will cause unspeakable damage to the alternator should it get caught in the rotor. Disconnecting the socket plate gives easier access into the alternator. Start by routing the cable ties around the back of the frame, then closing up over the capacitor body. Do not be tempted to poke or prod anything metallic into here to help, as doing so could damage the lacquer or the insulation on the windings. It pays to source a good quality capacitor. As mentioned previously, should this capacitor fail, you will have no AC output and your generator will be rendered useless. I find that the metallic bodied capacitors are often superior quality. The brand I prefer to use is called Electronicon. As I found out in my case, the ties I'm using are not long enough to make it round the capacitor in one complete loop. In this case, I simply join two ties together to extend the length. Then I will use another set of ties to support the opposite end of the capacitor in a similar manner. Once the ties are in place, cut off the excess material. I find a knife is best for this task, as it leaves a flush finish and no sharp edges that all too often get left when using side cutters or snicks. Once the capacitor has been held in place with its second set of ties, go ahead and reconnect the spade terminals. Polarity does not matter in this case as it is alternating current on the capacitor. Reconnect the main output winding connector as shown here, checking the output cables for signs of abrasion or damage which may have been caused by vibration over the years. Locate the panel onto its screws either side, then rotate slightly to lock in place before tightening down. Congratulations, the maintenance has now been completed. Going the extra few steps, as explained in this video, is guaranteed to keep your generator in working order, so that you can depend on it running correctly when you need it most.